Alright, now we're going to be solving quadratic equations by factoring. The reason why we learn to factor is to solve quadratic equations. What makes this a quadratic equation? It has x to the power of 2. And a can't be equal to 0, because if it was equal to 0, then you wouldn't have the x squared, and you would go back to algebra 1. Because the largest exponent would be 1. But no, we have this x squared. You can have b equal to 0, and it's still a quadratic. You'd have no b. You could have c equal to 0, and it's still a quadratic. You could even have both b and c be 0. But as long as you have that x squared, makes it a quadratic. Now, to solve, we set it equal to 0, and we factor. Once we set the quadratic equal to 0 and factor, now you notice my exponents are broken up. That's the whole idea. We factor to pull the exponents apart, and now I have two equations. I'm going to set them both equal to 0, because either one could go to 0, and if you're multiplying, it would still equal 0. So x plus 3 equals 0, minus 3 from both sides is negative 3. X minus 2 equals 0, add 2 to both sides, it's positive 2. And those are your solutions. The principle of zero product is just saying, hey, either one of these could be 0. 0 times anything is 0. It's already factored for me, and I know it's factored because there's a 0 on one side. So x plus 1 equals 0. That happens when x is negative 1. X minus 7 equals 0. That happens when x is positive 7. Here, I'm factored. I have my 0. I'm going to set them equal to 0 separately. X equals 0. That can be a solution. 4x minus 7 equals 0. I'm going to add 7. Divide by 4. X equals positive 7/4. Here, set them equal to 0. Plus 1. Divide by 2. X equals positive 1/2. Minus 4. Divide by 3. X would be negative 4/3. Two solutions. So it's not going to be factored for me. I'm going to have to factor. So we're going to use factoring to solve. We factor to solve. So we make sure it's set equal to 0. Notice now we have an equation. That's when we're solving. Set it equal to 0. Factor. Set them separately equal to 0 and solve to get your two solutions. In a quadratic, you could have one solution, two solutions, or no real solutions. So we're going to be solving by using all our factoring rules that we've learned in Chapter 6. So I make sure it's set equal to 0. It's in the order I need it to be. I have 3 terms, and the leading coefficient is 1. Same sign, both positive. 2 numbers that multiply to 4 that add to 5. So I'm factoring like we have been. Now we just take it this one extra step and get our solutions. So my two solutions are negative 1 and negative 4. If I plugged in either one of these in for x, it would come out to 0. Alright, I want to solve my quadratic. I have no c. You notice I have a is 1, b is negative 4, no c. It's set equal to 0. The first thing you always need to do is check, do you have a common factor? You do. It's x. Let's pull that out. X times x gets me x squared. X times negative 4 will get me negative 4x. Set them equal to 0. My solutions are 0 and positive 4. When you have no c, one of your solutions will always be 0. here I have two terms. I have a common factor though. They're both divisible by 6 and x. Pull that out. 6 times 2 will get me 12 and an x plus 1. Now it's factored. Set them equal to 0 to solve. X equals 0. So 0 and negative 1/2. Okay, let's do some more examples. Here I have a 4. I want to see, is everything divisible by 4? Yes. I pull that out first. Then I factor x, same sign, both negative. Two numbers that multiply to 3 that add to 2. We cannot factor that. The only numbers that multiply to 3 do not add to 2. Had this been a different sign, we could, but that's not factorable. Okay, here I have my 0 over here. I have two terms. I have a perfect square minus a perfect square. So I have a difference of squares. So break up that one, square root, one of each sign. Now it's factored. Set them equal to 0 and solve. So x is equal to negative 4 and positive 4. Here I have two terms, a difference of perfect squares, factor, and then solve. So minus 3 divided by 2, x will be negative 3/2, and x will be plus 3 divided by 2, positive 3/2. I'm jumping down to this one. Notice I don't have a 0 here. I have to set it equal to 0. Everything has to be on one side and a 0 on the other in order to factor together to solve. I have a difference of perfect squares. When I set them equal to 0 and solve, I'll get positive 4 divided by 3 and negative 4 divided by 3. Two solutions. First, I set it equal to 0. Make sure there's a 0 on this side. Then I can factor one of each sign. Two numbers that multiply to 28 that subtract at 3. The bigger one has to be negative. Set them equal to 0. X is negative 4 and positive 7 are my solutions. Here I want to get rid of this negative sign. Let's pull out a negative sign out of everything like you're dividing out a negative 1. Then I have to do a times c. Factor. Two numbers that multiply to 42 add to 13. Then I have to divide by a. that was a subtraction. Then you set them equal to 0. X will be positive 3 and x will be positive 7/2. If you don't have a 0 over here, I'm going to have to distribute this first. Then set it equal to 0. Bring the 18 over. Then factor. Two numbers, multiply to 18, subtract to 7. Set equal to 0. X will be -9 and positive 2.